I went down a few rabbit holes trying to fix it because I made the mistake of assuming that when it was first made, it was in a condition that was good, and I had to get back to that state. And I have discovered that this particular concept of how to do an HT fuse through the center tap to ground in this amp, in this circuit where you have an HT derived negative voltage supply, which turns into your bias supply, has got a big flaw. And that flaw is simple. If this HT center tap connection goes away because the fuse breaks, the fuse trips, or the fuse were to be omitted, but the power to the amp is still on, then while there's no current available to the positive stuff, the B plus, the tubes, and you won't have any output, the fuse will do what it's supposed to do in that regard, because the HT secondary is directly feeding this low voltage supply, and it's only on one side of the HT supply. Then this negative voltage supply gets all the potential voltage that the transformer can provide. So instead of having about negative 350 at this node right here, you get negative 750. And this node here is the same as this node here. When this amp first came in, it had a 3.3K resistor right here that was burned, had a 22 microfarad 500 volt cap here that had exploded. And I initially thought that the sequence of failure was that an output tube had an issue, and because its grids are directly tied to this through these 220K resistors, that whatever the short condition in the output tube, because grid failures do happen, stressed this 3.3K resistor, which then began to get hot. The heat from that resistor damaged this capacitor, and over a little bit of time, it got to the point where that resistor actually physically burned. And at that point, the heat from that, probably actual flame, caused this cap to explode. I now think the sequence was different. I now think that there was a fault in one of the output tubes, which caused this HT center tap fuse to blow, but did not cause the mains fuse to blow. And this would be exacerbated by at whatever point the owner replaced the 4 amp mains fuse with a 6 amp mains fuse. So the HT stayed on because the mains fuse wasn't tripping. It had no path to ground through the the HT fuse here. So all this was essentially off. But instead of having negative 350 volts present at this point, it had negative 750, which exceeded the ratings of that capacitor. Now, granted, there's very low current, but when you exceed the voltage capacity of a capacitor to that degree, you can have big problems. So I think it was what happened is that over voltage, maybe over a period of time, caused that FNT cap to fail. And once it failed as a short, and then there was a dead short hanging off that 3.3K, and that's when it burned. So rather than the resistor burning, damaging the cap, I think the cap was damaged, and that caused the resistor to burn. So the fix is, rather than having the HT center tap fuse to ground, this wire will just get moved to this other side of this fuse holder, because it's used with a bit of bus wire for a main grounds point. I'm not going to redo all that. This can stay in the amp. Doesn't matter if there's a fuse in it or not. It won't be in use. And a new HT fuse will be added here between the power receptacle and the on switch. And I will run a wire from the junction of the diodes to it, and from there to the first bank of filter caps. And that will be well. I may also change the standby switch from switching high voltage DC between this node and this node to being an interrupt on the HT secondaries going to the diodes for the rectification, because switches can handle high voltage AC much better than they can handle high voltage DC. It'd be much longer in service, much less prone to issues down the line. if I do that, it's important to note that the low voltage supply, the negative voltage supply, it's not a low voltage supply, it's just very, very negative, would always stay connected to one side of the HT center tap. Not center tap, but the HT secondaries. Secondaries with the center tap have some weird behavior modes. This is a very unique situation where you have two supplies derived from this and one derived from only one side. I'd have to model this in SPICE. I think if this negative voltage supply was derived from both sides of the HT that rather than just one, this may not still have happened. It's a weird thing. But anyway, this is not meant as an indictment of SL amps. This is a weird failure mode, and it's easy to miss. Certainly, so many large model, large number of amps that made by very large companies, even very expensive ones, have had much more fundamental flaws than this, very pervasive. I'm not going to name names, but as builder mistakes go, this is fairly obscure, easy to overlook, and it won't bite you till it bites you, but it bit the owner of this amp. So if you're SL amps and you're watching this video, please know that I mean this with great respect. You got 99.9% of this, not just well, but great. It's that remaining percent that caused all the burn problems here and shorted out these two filter caps. Well, it may or may not have shorted out these filter caps. It may have been some other issue which damaged those caps, which led to that fuse being tripped, which led to that situation. Everything's an interrelated system. That's why I stand behind adding these cathode fuses for each output tube. That way, if this tube fails, it doesn't take out all four tubes. If one of these tubes fails, it doesn't take out the low voltage supply, which is connected directly to the grids of those tubes through these 220K resistors. And if there's a short here, it will trip an HT fuse that's in line rather than tripping the HT center tap fuse. So even if this were to short again and blows the new HT fuse, this would still stay well below the rating of the filter cap for it, rather than going to 750. Until I get all this resolved, these two 22 microfarad 500 volts in crude series setup will stay in the amp, because I know that even if this goes up to 750, these caps will be good. I'm pretty sure that the one I used before, which was rated for 500 volts, is toast. I'm not going to test it. It was exposed to 750 volts long enough that I just bend it. I've got others. So I know what to do to fix this. It's an odd thing. Not a lot of people would have predicted it. Some guys would. This is the kind of thing I certainly would have modeled in SPICE myself before committing to a build. And this is the kind of thing when you do build an app, on your first prototype, what happens in every possible failure condition? What happens if, okay, this tube goes out? What happens if this fuse blows but this one doesn't? What happens if I get a short here? Does that affect the other voltage supply? And again, I'm really not trying to make SL amps look or feel bad. This is a very well built amp. Let me go down to the pretty side. By the way, all this stuff that I've been doing as test will be beautiful when I'm done. This is all temporary. This is not my work. This is not the fix. This is troubleshooting, and it's faster to work like this when troubleshooting. Just so you know, if this is the first video you see on this amp, or this is the first of my videos you ever see, this is not what my work looks like when it goes out the door. But this is faster when tracking down weird problems. I'm doing everything neatly at the moment. Like I said, everything else he did was done very, very well. Very neat wiring everywhere. You got the right amount of tension and support to it. Everything's held together, nothing strained. Very good lead dress, very good components. He took the time to find and mark and implement correctly the outer foils on the caps. Very good solder work throughout. This is not an indictment of him. And, if this had been one of his overdrive specials, I'm sure it would not have had this problem, because the overdrive special does not have that huge negative voltage derived from the HT the way the SSS does. So, all of us are learning as we go. And I have made mistakes myself. I hope to continue to, because that means I'll be breathing. And I've gotten fond of that over the years.